as mentioned before, we can expect there to be a growing amount of data that is very spatiotemporal by nature. So we can expect time series of remote sensing imagery coming in at really high speeds with satellites taking pictures multiple times a day even. So we will certainly have to see a development in this area for tools that can handle this kind of data and provide access to and provide analytical capabilities for that kind of data.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Anita Graser, and Anita has been on the show before. Back in episode 60, she came along to teach us all a little bit more about geospatial Python and her work with Python. So if you are interested in getting started, if you're looking for an introduction, or if you are a geospatial Python enthusiast, I would highly recommend that you go back through the archives and check out episode 60. Today, of course, we're going to be talking about something a little bit different. We're going to be talking about temporal spatial data, the tools that are available, why it's so difficult, what are the limitations, and what it might look like in the future. So during this episode, Anita mentions a whole lot of really great resources and links, and if you would like to get access to those, they will be on our website, mapscaping.com, after this episode goes live, and I also send them out in a weekly email. So if you'd like me just to email you all the show notes and links and resources mentioned today, go along to mapscaping.com/podcast, sign up for an email, and I will send them out to you. Okay, that's it from me. Let's get on with the interview. Anita, welcome back to the podcast. Appreciate your time. You've been here before. Last time we were talking about geospatial Python, and you gave us a ton of great insights into that and ways to get started with Python programming if we're not familiar with it already. So that was awesome, and I'd really encourage the listeners to go back and to listen to that, and I'll be sure to put links in the show notes to that episode. But today we're going to be talking about spatial temporal data, and I think now it'd be really great time for you just to give us a brief introduction to yourself and of course to your work with Time Manager in the QGIS project, just to sort of set the stage a little bit.
Sure, thanks Daniel, and thanks for having me again. My story with spatiotemporal data goes back 10 years, a bit more than 10 years actually. I studied GIS, and when I then got my first gig, basically working as an GIS expert in applied research, it was with traffic data. So they had traffic speeds and movement data on the road network. So basically everything there happened in space, but also in time. And I quickly had to realize that the GIS tools that were available, they were great with dealing with time, with space, but as soon as it came to time, it was really tedious to set filters, to see if there's any patterns, to even just evaluate the data. So that's basically the itch that I started to scratch when I started developing the Time Manager plugin for QGIS 10 years ago. Just yesterday, I dug out some videos which go back to showing Time Manager in QGIS 1.7. So that was basically in 2011 some point. And I've been maintaining the plugin ever since, and it's been used in so many different ways, which I find really exciting, like archaeology, for example, or mapping population properties. And now, of course, there's been a lot of COVID animations made with Time Manager as well.
So first, let me say thank you so much for creating this plugin. It's something that I've used before, and I've seen a ton of great visualizations being made with the use of that. So I really, really, really appreciate your efforts there, and I'm sure the community appreciates them as well. Thanks so much. So that was 10 years ago that you created that. You've been maintaining it ever since. Why do you think people hadn't focused on this before? Why was the temporal side of things almost like an afterthought when we think about geospatial?
That's an excellent question. We are all aware of this famous quote that everything happens somewhere. It stands to argue that also everything happens sometime. So it's a really good question why those GIS standards that have been implemented everywhere, the simple features standard, why they completely ignored the temporal aspect of the data. It might be due to it not being a big issue back then. You just had very little data and certainly no large-scale tracking data like you have nowadays, which is obviously spatiotemporal by nature. So it just might not have been on the mind of the developers of those standards. And then we ended up with software that was written for those standards, and it didn't have temporal in mind either. It's also very, very hard temporal. Anyone who has ever worked with timestamp, and even if it's just in an Excel spreadsheet, they know that there's dozens of different conventions for writing timestamps, and it's always a huge pain to work with those things. So once we had software which was not spatiotemporal by nature, but just spatial, every time you wanted to do something with time, it just got really, really hard. And I think that generally keeps people from doing it.
Yeah, I guess right at the start we were trying to solve a spatial problem, right? And then later on we're like, oh, this also has a temporal component, so let's add that onto. So I can kind of get that, and I think too when we're talking software development, it's one step at a time. So to solve that problem and then move on to the next one. So I can see how this was sort of added on with time, and as we progressed and realized that okay, we're getting greater access to data, and we're interested in seeing movement and behavior over time. Perhaps we're even interested in modeling things. So I can understand how these things were sort of built on later on in the process. But let's talk a little bit about this. So that was 10 years ago. Obviously, we've come a long way. What kinds of data can we use to store spatial temporal? Just restricted to vector data, or can we use other things?
There's actually tons of different formats that can have a time aspect. Basically, all of them can. Some of them do support it more natively than others, however. So vector was the one that I initially thought of when I developed the time manager. In the vector case, you basically have the possibility to add timestamps in the attributes. You could also have timestamps in metadata or in the layer name, but usually it's in the vector attribute, so every feature has timestamps. With rasters, it's usually the case that you have to put the time information into the file name. So for Time Manager, there was a raster support that enabled you to parse the time information from the layer name automatically, or otherwise you could input it manually. Then there are some file formats like netcdf, which were also supported by Time Manager, and they are a bit more sophisticated. So they can actually store proper time information, and you have layers with associated time information which can be read automatically by GIS tools that support them, and then you can have animations of those. And there's also more even rarer data sets which I haven't worked personally with, but for example, mesh data, which seems to be popular in hydrological applications and also in meteorology. For example, some people might have seen those fancy animations that have been created by Lutra Consult for QGIS with animated meshes. They look really great, and they show like the movement of the wind and how hurricanes form and all such things. So there's really a tons of different formats that you can work with and that you should support if you want to create software that is spatiotemporal.
So I can definitely see that with vector data. I mean, that makes perfect sense to me. And I think most people listening to this podcast will understand how we can attach a time to a geometry in the attributes of a vector data format. Raster, I think, is a little bit more interesting. So now we're talking about cloud optimized geotiffs, for example, where we can segment data. You know, we can look into a geotiff file and pull out just the data we're interested in. Could you imagine doing this by time as well? Do you think that's going to be a possibility in the future? Not just a spatial segmentation, but a time segmentation?
Absolutely. I think with recent developments in remote sensing technology, we will have huge amounts of imagery time series, which can be then slashed spatially and temporally. And that's one of the big challenges, and also why we need tools that can efficiently handle large rasters.
Okay, so now we've talked a little bit about spatial temporal data. In general, we've talked a little bit about the data formats we can use and the possibilities within those formats. So it seems to me that we have like time management, for example. I know we have other tools that can deal with this. We have data formats that can deal with this. Why is it so hard?
It's hard because there is no standard. Every developer has to figure out how they want to handle the time, and or every user has to figure out how to handle time, because there is no common understanding of how things should be modeled and how they should be called. Because in simple features, for example, we have an encoding standard which tells us how we should store the features, and we have an access standard which shows us how which functions should be applied to the features and what are they called. Like you can calculate intersections, and you can check if features touch in the geometry. All those things have been specified and standardized, so it's comparable in different GIS, and analysts know what they get if they understand the functions. We don't have anything similar in the spatiotemporal area so far. Well, there's one caveat. There is actually currently under development moving features standard. So not simple features, but moving features, and it's also part of the OGC standards. So they are working on representing spatiotemporal phenomena in this standard, but it has so far received very, very little attention from the developer side. There's also some shortcomings to the standard which make it a bit hard to implement it, to be honest. But basically it comes down to that. Everyone who started working on it had to start from scratch and figure things out. And if you have some functionality in one tool, you will not find exactly the same functionality in another one. Of course, it's more complicated than if you just look at the spatial aspects. For example, if you think of spatiotemporal data that could be changing country boundaries or plot boundaries in a city. So you could split plots into multiple parts because a plot gets divided, and then there's multiple owners for the former one plot. And later on, some plot parts could be merged again. And if you want to track all this evolution of the ownership and how the spatial and spatiotemporal relationships with neighboring plots look like, you can imagine that it gets a bit more complicated than just the basic spatial primitives of whether two polygons touch or not.
Yeah, yeah. To be perfectly honest, I'd never thought of a lot of this before. And I think it's a really interesting idea that if we could take those, obviously not the same standards, but the same sort of rigor we have around geospatial standards when we talk about geometries and their attributes and their functions, for example, and apply that to time series data as well. I mean, that's really interesting in itself. I was wondering there, so you're talking about the changes of a city limit, for example, and trying to represent that over time. Today, what does that look like? And I guess what could that look like? Is it, do I have to store that geometry every time it changes, or is there a way of sort of packing it into one feature and having time change it? What does that look like today, and what might it look like in the future?
Yeah, that's an excellent idea to pack it all in one feature. I haven't seen it done like that so far. So usually with those boundary polygons, for like administrative areas, you will have certain time slices, because the administrative areas, if they change, then there's a certain date when there has been a new law or a change in regulations, and then you have a new set of administrative areas from then on forward. In my experience, very little history, so you usually have a rather hard time tracking, okay, this area or this address, for example, was part of the administrative unit A in 2020, and 10 years ago it was part of some other area. Usually have to do some spatial joins to even figure out how the history of these units were, because they don't have the information stored that these areas originated from the old areas. That gets really hard. There's usually no history, and even if you think about how you could do it, it's not as simple as just splitting it cleanly into new subdivisions. Sometimes it's a merge and split at the same time, like the redistricting that happens in the US quite often. There is no clean history. That's why we have those time slices. So every couple of years, you get a new set of administrative units that you need to work with. In other cases, like if you have property maps and plots of land can change ownership continuously, then you also have the geometry stored multiple times, and every time the geometry usually has a new owner attribute attached to it. I'm also not aware of anyone who's really trying to do these kinds of modeling in a way like you envisioned, that there's one feature entity which is tracked over time as an object.
I can definitely see the problems like when we're dealing with historical data. But I think going forward, if we think about the Internet of Things, for example, that's going to be a very high frequency update we're going to get. So when we're looking to model things and track things and monitor things over time, I think with that higher frequency data, we're going to have to think about how we do it, how we store those features, but also how we represent them as well. And I think a lot of those, or some of those problems that you're talking about anyway, I hope that they will be less significant going forward.
Yeah, for a subset of spatiotemporal features, it's a bit easier. I think if you look particularly into tracking moving features, particularly if you make it as simple as just having moving point features, then you can really consider this one feature an entity by itself, with its own properties, and then you can track it over a certain period of time. That also applies to moving polygon features to some extent. So for example, if you want to model a storm, you could have the extent of the storm, the hurricane, for example, as a polygon modeled over time. That's certainly a possibility. So for a subset of spatiotemporal, I think there are quite a few approaches nowadays that are promising.
I just want to touch on one thing here, and I'll let you dive deeper into this, but space-time cubes. Can you talk a little bit about that concept?
Sure. So space-time cubes are one of the visualizations that we sometimes find in GIS tools for dealing with movement data. The idea basically is we use existing 3D rendering capabilities, and we have XY on the plane, and then we put the time dimension on the z-axis. And with these, you can do visual exploration of smaller movement data sets, because you can see quite easily if there's just a vertical line, it basically means that there's no change in x and y dimension, and the object just stays at a certain place. And then when it starts moving, you can see diagonal connections to other places. Depending on how steep the diagonal is, whether something travels fast or slow. And if you have multiple objects in that space-time cube, you can probably see if they meet somewhere either along the way, or they even spend some time together in space and time. So this basically makes it possible to do exploratory analysis, because it's usually just a visualization and it doesn't come with automatic tests like the one we mentioned before, where I said, did they really meet at the same space at the same time? But you can have a look at those, and they are supported in some GIS and are also quite easy to do yourself if you have something to plot in 3D dimensions. The only challenge there really is as soon as you have more than 3 or 4 objects, it usually gets pretty hard to see the patterns, because it gets messy really quickly. So there's a huge challenge in exploring larger movement data sets. And that's something I've been also working on in my research recently. One of our recent papers should come out soon, and there we looked at the movements of thousands of ships in the open sea, for example, and that's not something that you can do with a space-time cube. That's why we introduced some other concepts.
It's really interesting when I hear you talk about concepts like space-time cubes, for example. It really feels like the visualization of this, spatial temporal data is, racing ahead of the actual analytics behind it, if that makes sense, or the structured approach to it. So you were mentioning there's some great visualizations, but can you actually trust them? Can we do any analysis on them and rely on the fact that, okay, that this is a standard way of doing it? We know that this is, just because it looks like that, we also can test and get some analysis out of it and say, yeah, it is actually like that. They did meet in space and time. I think that's really interesting, that the visualization feels like it's sort of ahead of the actual the grounding or fundamental concepts of it.
Yeah, I don't think it's that black and white, to be honest. It's not like we have a ton of good visualizations to deal with spatiotemporal data. Most of them if they are not the space-time cube, then they are animations. And animations are known to be notoriously bad for really detecting patterns reliably. There is this change blindness effect that has been proven multiple times over and over. So people are just not good in seeing certain changes in animations. They're much better at it. For example, if you show them some small multiples, so multiple small maps next to each other, then the results would probably be more reliable. But it's not as fancy. So most of the time we have some spatiotemporal data visualization. The focus is to make it fancy for some decision makers or to attract attention for a news piece. If you really go into the analytics, most of the tools that we currently have, they are not very visual. There, the danger is that you trust the summary statistics too much. And that's one of my pet peeves as well. So particularly if you work with mathematicians and statisticians a lot, they like to do their statistics, their tests for significance. And they usually don't do a lot of raw data or even spatiotemporal visualization to get a feel for the data besides doing those tests. And I think we need this middle ground, this understanding of the raw data before we can actually do tests, like checking for how long certain entities have been in a vicinity closer than 20 meters, for example, if you want to test if someone met. Of course, you can do that. That's not rocket science. But to understand if the data is actually reliable enough to determine those 20-minute intervals, or whether you need to say, okay, we cannot tell it any more closely than they might have met in this 1 hour. That requires a thorough understanding of the data, which you cannot get if you just apply some statistical tests to it, in my experience.
Thanks very much for taking the time to sort of go a little bit more in depth with that. I really appreciate it. I would like to sort of not push back, but just sort of mention here that I think that animations, it's really interesting to hear you talk about that change blindness effect and the other side of it as well, that people perhaps aren't spending or trusting that the summary is too much. And I think it really depends on who your audience is, right? Like what kind of output, what kind of message you want to send to them. I think if you are creating a newspaper, for example, a newspaper article, then sending out the raw data isn't that great. But if you're trying to spread the message out broadly, then I think it's really important to have lots of different tools that you can use. So depending on who you're talking to, raw statistics or raw data might be a great one. A summary might be another good one of trying to get your message out there. But I definitely think there's a place for those animations in terms of communicating messages to perhaps a broader audience.
Oh, yeah, absolutely. They are great for communication and for bringing a story across, particularly if you combine them with some text and context information as well. The real problem of change blindness and related problems is really if you use the animation as a data scientist to do your analytical work. That's where I would be careful. But if you want to use it for communicating and you know your audience, then they're certainly a great tool.
So I want to move off a little bit now because we've talked about spatial temporal data, why we need it, why it's difficult. We talked about the kind of the options we have for storing this data in different file formats. We've talked about why it's hard. At the start of the conversation, we also talked a little bit about some of the tools that are available. I wonder if we could dive into that now. And I'm assuming with your background, we'll focus a little bit on QGIS here, and that's fine. But could you talk a little bit about what tools can we use today to deal with this kind of data?
Yeah, so if you use QGIS, then there's a plugin for that. There's usually a plugin for everything. So there's also a plugin for spatiotemporal data, and it's called Time Manager. And Time Manager started off as I mentioned in the beginning, my own little tool to deal with traffic data, to look into how speed changes on road network links over time and how vehicles move in the network. So as you can hear from that, it was initially focused on vector data, on moving points, and on lines whose attribute values changed. Naturally, if you support points and lines, then it would also support polygons, because what it does basically on the methodology side is it puts a filter on those attribute values in the attribute table of the vector layer. and it filters out all the features which are not within the current time frame of interest. People mentioned that they also have some raster time series. It's usually like those temperature rasters that can be on a global scale, and they had multiple years of those and they wanted to animate those. I implemented some support for that. Basically, it gets the year or the timestamp information from the raster layer name, and it can also then turn on and off the raster layer, so it also looks like there's an animation. Because the key idea was you load in all those different layers with your time information, they are automatically synced, and you get a play button which you can press, and then you have the animation directly in your GIS tool. And if you want to preserve the whole thing, you can also export the animation as a series of images, which you can put in PowerPoint presentations, or you can stitch together in an animated GIF or in a video. Over the times, because it's been such a long time, a lot of different things have been added as well. So I already mentioned the NetCDF support. There's also a really interesting aspect in web services. So I guess everyone's familiar with the Web Map Service WMS standard. There is actually an aspect, a temporal support in the WMS standard, which is still rather rarely used, but it works pretty well, particularly in GeoServer, in my experience. Basically, whenever you request a map from the web server, you can send it also a timestamp or a time frame for which you want the map to be drawn. And this can be combined with the capabilities of Time Manager to basically create an animation in your desktop GIS and fetch the individual maps from the web server dynamically, which is really neat, particularly if you have huge data sets on the server side that you want to explore in this kind of fashion. Besides the Time Manager plugin, there's also been some folks who have taken it to the next step and have used Time Manager configurations in QGIS project settings. And you can publish them on the web and also have Time Manager functionality in your web GIS. So basically, it goes full circle. If you use some web map service, for example, you can then replay it in the web browser as well, which is pretty cool.
So I guess the elephant in the room here is that the Time Manager is retiring. Can you talk a little bit about what we're moving towards in terms of Time Manager or spatial temporal data in QGIS?
Sure, yeah, Time Manager is retiring, and I've written this blog post where I was a bit provocative and I said it's dead. Of course, it's not dead. It will be around. The code is online forever, probably, in the plugin repository. But the idea is, and it's been in the makings for quite a long time, to finally bring the temporal support to QGIS core. So that means you don't need any plugins anymore, and the spatiotemporal filtering will hopefully become as performant as the spatial filtering has already been for a long, long time. Core developers started working on that to add the capabilities for different layer types and to have spatiotemporal settings now in the layer properties of raster layers, of vector layers, of mesh layers. Basically, what you get now, starting from QGIS 3.14, which will be released soon, is the so-called temporal controller. If you start it, it looks kind of similar-ish to Time Manager naturally, because it also has these like video control buttons for play, forward, backward, jump forward, go back to the start. It's just a real treat to work with. It has the flexibility that we had with Time Manager, plus it has the integration with QGIS Core that we always were dreaming of, but was just really difficult to realize in a plugin. It also enables us to do now is to script all those configuration steps. In Time Manager, you had this semi-nice-ish graphical user interface to add layers manually to define what is the start timestamp, what is the end timestamp, and what are the intervals that you want to work with. But in the temporal controller, you can figure it out once, and then you can write a Python script to reproduce the configuration for as many layers as you want. So I just recently had the opportunity. Someone sent me a folder with a couple of GPS tracks, and basically every GPS track was its individual file. And in Time Manager, I would have had to add every one of those layers by hand. But now with the temporal controller, I can just go and say, oh yes, for every file in this folder, just load them, set these settings in Python, and then basically press play. Yeah, I'm really happy. Bit sad maybe that Time Manager is retiring, but it certainly frees me up to start some new projects, and I've got them lined up already.
Yeah, I want to move off and talk about those in just a second. But okay, so like we come full circle again. We have this problem with spatial temporal data. We have data formats that are going to help us deal with it. We've talked a little bit about why they're difficult at the moment. We've talked a little bit about some of the tools, especially in QGIS, we can use to deal with them. Perhaps we could move off now and talk about how can we avoid some of the common mistakes. If I'm creating data, if I'm setting up my monitoring activity, what can I do to help make the process more simple for somebody else who might later on be analyzing the data? What things should I be thinking about?
Yeah, the usual or the biggest problem is that there's so many different conventions for how to store time information. Don't even get me started about the American standard with starting with the month and then the day and then the year, which just messes everything up. I would usually recommend to stick to the ISO standard timestamp formats. So it's always the year first and the month then the day, because in that's the only reliable format where you can really sort the dates. But in any case, it should be probably documented what the formats is, because people will have to look it up and to verify that they got the parsing correctly. Beyond that simple issue, unfortunately, whenever we deal with timestamps, there's of course also the time zones issue. For example, first of all, of course, you again have to document which time zone you're talking about. And if you have global data sets, it gets even more important to do that. Whether everything is, for example, stored in UTM, in UTC, or whether you have local timestamps can make a big difference if you have some tracking data and you want to calculate the movement speeds and directions, for example. For example, if you store your movement data or your spatiotemporal data in a database like PostGIS, the database server will have a certain time zone setting, which either is your local time zone or it's set to UTC, which also happens quite often. And then there's always some application logic that thinks it's very clever, and it tries to transform from UTC to the local time without telling you. And then you wonder why there's a 2-hour gap, for example, between the data that you're looking at and what you can see as raw data in the database. And those things can be really ugly and mind-bending at times. One has to be aware of them, and it still sneaks up on you and surprises you sometimes, for sure.
So thanks for taking the time just to give us a brief rundown on some of the things we should be thinking about before we start, recording time series data, and some of the problems it might cause in the future when we come to analyze this data if we don't think about it right at the start and sort of build those ideas and that documentation into the structure of whatever it is that we're doing. So I really appreciate that. I'd like to move off now and just talk about the future a little bit. So what can we expect to see in the future when we think about spatial temporal data, tools, and services? Is there anything on the horizon that's particularly exciting?
Absolutely. So, as mentioned before, we can expect there to be a growing amount of data that is very spatiotemporal by nature. So we can expect time series of remote sensing imagery coming in at really high speeds with satellites taking pictures multiple times a day even. So we will certainly have to see a development in this area for tools that can handle this kind of data and provide access to and provide analytical capabilities for that kind of data. We also see a growing number of data sets that are like weather and climate related data sets in meshes. So I think the integration of that kind of data sets in GIS will also be growing. Personally, for me, also there's this big, continuously growing amount of tracking data from a variety of sources. It can be GPS tracking of animals, of vehicles, of goods, or it can be other locationing systems that are used for tracking, like Wi-Fi or Bluetooth, or even the cell information from mobile phone calls that has quite different characteristics than GPS tracking because it's more coarse, but it's still tracking information that has a huge potential for understanding our mobility and how we might improve how the mobility system works also. And for me personally, what I'm working on now that I have extra time because time manager can be retired is a new project, and it's called Moving Pandas. It's a continuation of what we discussed in our last podcast episode, where we talked about how pandas works and that its background is in finance and time series analysis, and that people have been working on building on top of pandas to add spatial support to it in GeoPandas. And what I'm doing in Moving Pandas is I'm basically taking these things, the spatial and the temporal part, and I'm meshing it together to make something useful for movement data. We have a lot of visualization options and background maps already integrated. What we currently don't have yet is 3D visualizations with a map, because the GeoPandas plotting libraries so far are 2D, but I think we'll be getting there as well. And the interesting thing is, as soon as I started building Moving Pandas, and I only found out about it afterwards, there's at least 2 or 3 other projects which had a similar idea. So they are also building on pandas, and they are adding functionality to deal with movement data. So we will see how these develop, if they will converge at some point. But I think it's certainly the right point in time to start doing this kind of work.
I completely agree, and I look forward to following along and see how this develops. I really want to thank you for your time. Thank you so much for coming on the podcast again. It's always a pleasure to talk to you. Really appreciate your insights and, of course, this massive body of work that you've amassed over the last 10 years and all the contributions you made to the geospatial community. Thank you so much for that. It's much appreciated. I'm thinking with Moving Pandas, people can go to your website and find out more. Is there anywhere else people can go to reach out to you or learn more about what it is that you're up to?
Sure. So basically all the contact points are linked from my blog. There's also a dedicated Moving Pandas website already at movingpandas.org. And the easiest way to reach out is probably on Twitter under GIS or on LinkedIn. You can also find me there.
Thanks again, Anita. I really appreciate it.
Thanks for having me, Daniel.
And that's it for another episode of the Mapscaping podcast. Remember, if you would like an email with all the notes, links, and resources mentioned in this episode, go along to mapscaping.com/podcast, sign up for the email there. I'll send that out to you very soon. Thanks so much for tuning in again this week. My name is Daniel. It's been a pleasure being your host. I look forward to seeing you again next week, and we'll talk then. Okay, bye.